Today's lesson is about exponential and logarithmic equations, so algebraically solving equations using exponents and logarithms. The first rule we're going to use is something called the one-to-one property of exponential functions, which basically says if b to the x is equal to b to the y, then x equals y. We can use the one-to-one rule for a problem like this. So 4 to the x plus 2 equals 16 to the x minus 3. So if I can rewrite this so that we have the same power, then we can eliminate the bases. We can rewrite 16 as 4 squared. So 4 squared, then the 2 is multiplied there. So now, since I have the same base, I can eliminate those. So I have x plus 2 equals 2 times x minus 3, and then we just have a simple equation to solve. So 2 is going to equal x minus 6, so my x is equal to 8. Our next problem, 1/3 to the n is equal to 1 over 81 to the 2/3. So I can again rewrite this. So this is going to be 1/3 to the n. To get from 81 to 3, 3 cubed is 81. So 1 over 3 cubed would be equivalent to 1 over 81, because if I cube 1, I get 1. If I cube 3, to the 4th power, make that 4. 3 times 3 times 3 times 3 is 81. So now I just have n equals 4 times 2 is 8 over 3. Next, we're going to use the one-to-one property of exponents to solve logarithmic equations. So our first equation to solve is 2 natural log equals 18. So we want to isolate the logarithm. So I'm going to divide both sides by 2. Then I'm going to use the one-to-one property to eliminate the logarithm by picking an appropriate base. So in this case, my base is going to be e. So we're working backwards. The other ones, we had the same base and we simplified. Here we're introducing the same base in order to simplify. The reason this simplifies is e to the natural log of x is just x. And then we can find the e to the x button on your calculator. E to the 9 is approximately 8,103.08. Our next example, 7 minus 3 log 10x equals 13. So if there's no log, if there's no base written there, that's understood to be 10. So again, we want to isolate the logarithm. So I'm going to subtract 7 from both sides. Then divide by -3. So that's -2. Now that I have the logarithm by itself, I'm going to introduce a base, and the base I'm going to introduce here is 10. So 10 raised to the log 10x is going to equal 10 to the -2. On this side, that just eliminates the log, so we just have 10x. 10 to the -2 is 1 over 10 squared, which would be 1 over 100. And then I divide by 10, so x is going to be 1 over 1,000. Our third equation here, log base 5 of x to the 4th equals 20. So first I'm going to use the power rule. Okay, then I'm going to divide both sides by 4. Now we'll introduce a base that gets rid of the logarithm. So in this case, that's 5. So x is going to equal 5 to the 5th, which is equal to 3,125. Next, we're going to talk about the one-to-one property of logarithms, which says if log base b of x is equal to log base b of y, then, quite logically, x has to equal y. So our next set of examples, we are going to be using the one-to-one property of logarithms and properties of logarithms to solve various logarithmic equations. So we have log base 2 of 5 is equal to log base 2 of 10 minus log base 2 of x minus 4. So the property that we're going to use here is the quotient rule. So this is equivalent to log base 2 of 10 over x minus 4. Now that I have the same log, I can eliminate them. So if log base 2 of 5 equals log base 2 of 10 over x minus 4, then we can just say 5 has to equal x minus 4. So I'm going to multiply this denominator over and distribute. So we're going to have 5x minus 20 equals 10. So 5x equals 30. So x equals 6. Our next example, log x plus log x minus 3 equals log 28. So we're going to be using the product rule here. So this side is going to equal log of, we're going to multiply x times x minus 3. So that's going to be x squared minus 3x. Now that we have the same log on both sides, I can drop them. So x squared minus 3x equals 28. Since we have an x squared and a linear term, that means we're going to need to factor. So we're looking for the two numbers that multiply to get a negative 28, add up to get a negative 3. So that's going to be negative 7 and a positive 4. So either x is equal to 7 or x is equal to negative 4. The original equation, however, contained logarithms, and we cannot take the log of a negative value. So if I plugged this negative 4 back in, we'd have a log of a negative. So even though numerically we got it as an answer, it doesn't answer the problem that we have. So 7 is our solution. Our third example, natural log of 6x plus 2 minus natural log of x plus 1 equals natural log 2x minus 1. So again, we're going to use the quotient rule here. So this side is going to equal natural log 6x plus 2 over x plus 1. So then we can drop it. So 6x plus 2 over x plus 1 is equal to 2x minus 1. Then we're going to multiply over this denominator. So this is going to be 6x plus 2 is equal to 2x minus 1 times x plus 1. So we're going to have to FOIL there. So 2x squared plus 2x minus x minus 1. So 6x plus 2 equals 2x squared plus x minus 1. Again, we're going to factor, so we need to move everything to one side. So x minus 6 is minus 5x, and then 1 minus 2 gives me a minus 3. Okay, so we're going to factor here. Lots of different techniques, but I prefer the just figure it out. So if this is a 2x squared, then our two things are going to have to be a 2x and an x. If this is a negative 3, then my only options are 1 and 3. One of them is negative, one of them is positive. So we just kind of trial and error to get to that negative 5. Well, if I multiply a 2 times a negative 3 and the 1 times a plus 1, that'll give me that middle term. So either x is equal to a negative 1/2 or x is equal to 3. In this case, though, the negative, again, isn't going to work. It's going to create negative values in our logarithms, and the 3 is just fine. So our solution is just x equals 3. The last set of types of problems we're going to solve are exponential equations. So our first question, 3 to the x equals 7. So obviously this isn't a whole number, because 3 to something does not equal 7. So we're going to use, to solve exponential equations, we're going to use logarithms. So we're going to use the one-to-one property of logarithms backward. So if I take the log of both sides, and you can do log base 10, log base whatever, I will typically use natural log. So natural log of 3 to the x equals natural log of 7. What this allows me to do is to get this exponent to no longer be an exponent. So x natural log of 3 equals natural log of 7. Now we can solve. So we're going to have natural log of 7 over natural log of 3. So on the calculator, we're just going to use our log buttons, or natural log in this case. So we're going to have natural log of 7, make sure to close parentheses, divided by natural log of 3. So we get 1.771. Next example, e to the 2x plus 1 is equal to 8. Again, to get the exponent from being an exponent, I'm going to take the log. This one, taking the natural log, is the natural choice. So we take the log of both sides. On this side of the equation, natural log of e to the 2x plus 1 is just 2x plus 1. So then we solve for x. So 2x is going to equal the natural log of 8 minus 1. So x is going to equal natural log of 8 minus 1 over 2. Plugging that into the calculator, you'll get about 0.54 as our solution there. Our next one, 6 to the x equals 2 to the x minus 1. So again, I'm going to take the log of both sides. Which allows me to bring the exponents down. Here, be sure to put this x minus 1 in parentheses, because it's going to get multiplied by both of them. Okay, so I'm going to distribute on this side. So I'm going to have x natural log of 6 equals x natural log of 2 minus the natural log of 2. I'm going to move everything that has an x to one side, so I'm going to subtract that. So we're going to have x natural log of 6 minus x natural log of 2 equals negative natural log of 2. I'm solving for x, so what I can do here is factor an x out, which will leave me with natural log of 6 minus the natural log of 2 equals negative natural log of 2. And then we're going to divide. So negative natural log of 2 over natural log of 6 minus natural log of 2. Then you type all of that into the calculator using careful parentheses. And you can also use the fraction feature, but you'll get a negative 0.631 when you do so. Our last equation, 1,500 equals 4e to the 0.045t minus 100. So we're solving for the t. First thing to do is add 100. Okay, I can't take the log and really reduce this until I get the e by itself. So I'm going to divide by 4. Now we can do the log, and specifically the natural log. So on this side of the equation, this side stays natural log 400. This, the natural log of e, cancels each other out. And then we just divide by 0.045. So t is going to equal the natural log of 400 divided by 0.045. Type that into your calculator. You'll get about 133.14. So that's how we can use exponents and logarithms to solve various types of equations.